Morning, my dear children. Today, the topic I'm going to discuss will be very interesting for especially class 10, which is arithmetic progression. In this introductory parts, I will explain the arithmetic progression and how it is built and how to understand arithmetic progression. Oftenly we see many things in nature which follow certain patterns. For example, the holes on a honeycomb, the grains on a corn cob, and petals of a marigold, and many natural patterns we oftenly find in nature. Similarly, numbers can be written in such a way that follow certain patterns or rule. Suppose consider the following list of numbers. Number 1, the pattern is here 3, 5, 7, 9, 11, and so on. Number 2, patterns here 5, 2, minus 1, minus 4, minus 7, and so on. You will see the another pattern number 3 is there 2, 4, 8, 16, 32, and so on. Number 4 pattern is here 4, minus 2, minus 1, minus half, minus 1 by 4, and so on. Number 5 pattern is here 1, 4, 9, 16, 25, and so on. Number 6 pattern is here 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. Here, each number in a list of number is called a term of the list. First, second, third, terms is here. We observe the following above the above list of number in here. In list number 1 is succeeding term is terms obtained by adding 2 to its previous term. In list 2, each succeeding term is obtained by subtracting 3 from its previous term, that is, each succeeding term is obtained by adding minus 3 to its previous term. Right? In list number 3, each succeeding term is obtained by multiplying its previous term by 2. In list 4, each succeeding term is obtained by multiplying its previous terms by minus half. In list 5, each succeeding term is obtained by squaring in next natural number. In list 6, each succeeding term is obtained by taking the reciprocal of the term natural number. In this chapter, student, we will discuss about pattern in which any term except the first term is obtained by adding a fixed number to its preceding terms or by the multiplying its preceding term by fixed non-zero numbers. We shall also be find the general terms and the sum of their first n terms and apply this knowledge in solving some day-to-day life problems. Student, In this part, I shall discuss about the arithmetic progression, as well as in the second part we discuss about the geometric progression. So let's start what actually arithmetic progression, and there regarding many terms that we define and discuss also. So let's start. So my dear student, here we understand the arithmetic progression, in short from A.P. Right? First of all, we try to understand what is sequence. A sequence is a set of number arranged systematically according to some rules. Each element t suffix n of a sequence can be associated with a corresponding numbers n. For example, in 1, 2, 3, 4, and so on. Here t suffix n is equal to n terms. Okay. Number two here, in 2, 4, 6, 8, and so on. Here t suffix n is equal to 2n. Right? Number 3 here, in 1, 3, 5, 7, and so on. So t suffix n is equal to 2n minus 1. Number 4, in 3, 5, 7, 9, and so on. Here t suffix n is equal to, we can write 2n plus 1. Number 5, in the sequence 5, 8, 11, 14, and so on. T suffix n here 3n plus 2. Right? So this is the sequence. Right? Now student, here we understand the finite sequence. A finite sequence has a finite number of terms and is written as this one, series. Now my dear children, here we understand a finite sequence. So what is finite sequence? A finite sequence has a finite number of terms and is written as T1, T2, T3, and up to Tn. Right? So here we also understand a finite A.P. finite A.P. A.P. right? The A.P. has limited term is called finite A.P. Here example number 1, 1, 2, 3, 4, 5, comma, up to 100. So it have a finite limit. Okay, so this type of sequence is called finite A.P. Right. Now we understand infinite A.P. Infinite A.P. Right. The A.P. has unlimited terms called infinite A.P. Here example number 1, 100, 70, 40, 10 and so on. It is this sequence, it is the infinite A.P. Right. Another example 4, 4, 4, 4 and so on. It is also a infinite arithmetic progression. Right, student? My dear children, here we understand a series. What is series? A series is an expression obtained by adding the term of a sequence. Suppose series of nth term, we can write here t suffix 1 plus t suffix 2 plus t suffix 3 plus plus t suffix n is a finite series. Right, student? Now student, here we understand arithmetic progression with definition. In mathematics, an arithmetic progression, in short form A.P. or arithmetic sequence, is a sequence of numbers such that the difference between the consecutive terms is constant. Difference here means the second minus the first. For instance, the sequence 5, 7, 9, 11, 13, 15, is an arithmetic progression with common difference of 2. Right. In the other way, we can say arithmetic progression is said to be in arithmetic progression if the terms increase or decrease by common difference. Generally, the first term is denoted by A and the common difference by D. Here, sequence and common difference right. Sequence here A, A plus D, A plus 2D, comma, A plus 3D, comma, and so on. So here the common difference is D, right? Now another sequence here, 2, 2, comma, 5, comma, 8, comma, 11, comma, and so on. Here the common difference you observe 5 minus 2. That means the second term minus first terms. Right here. So we can write is 3 here. Right. Now another sequence here, 3, 3, comma, 9, comma, 15, comma, 21, comma, and so on. So here the common difference is 6. Right, student? So here another sequence here, 15, comma, 10, comma, 5, comma, 0, comma, minus 5, comma, and so on. So here the common difference between the two consecutive number is minus 5. Right, student? Hope you understand the actual meaning or definition of arithmetic progression, in short AP. Right, student? My dear student, one thing you should remember: the behavior of the arithmetic progression depends on the common difference D. If the common difference is number 1 positive, then the numbers terms will grow towards positive infinity. Number 2, if the common difference is negative, then the numbers or terms will grow towards negative infinity. Right? For better understanding, if an AP is given, then its first term and common difference can be found. For example, if an AP is 11, 15, 19, 23, 27, and so on, then its first term A is equal to 11 and common difference D is equal to A2 minus A1 is equal to 15 minus 11 is equal to 4. Note that D can be found by using any two consecutive terms. Number 2, if an AP is 5, 3, 1, minus 1, and so on, then in that case its first term A is equal to 5 and common difference D is equal to A2 minus A1 is equal to 3 minus 5 is equal to minus 2. Right? Conversely, if the first term and the common difference of an AP are known, then the AP can be obtained if A be the first term and D be the common difference of an AP. Then the AP is A, A plus D, A plus 2D, A plus 3D, A plus 4D, and A plus 5D, and so on. For other example here, number 1, if the first term and the common difference of an AP are 7 and 5 respectively. That is, A is equal to 7 here and D is equal to 5 here. Then the AP is 7 comma 7 plus 5 comma 7 plus 2 into 5 comma 7 plus 3 into 5 comma 7 plus 4 into 5. That means the series will be in AP 7 comma 12 comma 17 comma 22 comma 27. Right, student? Number 2 example. If the first term and the common difference of an AP are 7 and minus 5 respectively, that is, A is equal to 7 and D is equal to minus 5 here, then the AP is 7 comma 7 plus minus 5 comma 7 plus 2 into minus 5 comma 7 plus 3 into minus 5 comma 7 plus 4 into minus 5 comma and so on. In that way we can write here in this AP 7 comma 2 comma minus 3 comma minus 8 comma minus 30 comma and so on. If A1 comma A2 comma A3 comma dot dot and so AN are in AP, then we can write A1 plus A2 plus A3 plus dot 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 plus AN is called an arithmetic series. Right, student? Hope this example helped to understand the arithmetic progression in the better way. My dear student, here we find out the nth term of an AP. Right? The term of an AP are given by T suffix 1 is equal to A, T suffix 2 is equal to A plus D. Right? Here A is equal to first term and D is the common difference. And so T3 is equal to, we can write A plus 2D. In this manner, this will be continue up to T suffix N is equal to, we can write A plus N minus 1 D. Right? That means A plus N minus 1 in bracket multiply with D. Thus, the nth term of an AP is nth term of an AP. We can write is Tn is equal to A plus N minus 1 into D, and is known as the general term. Right, student? I hope this one you understand very clear. Now my dear student, here we understand some of first n terms of an AP. Let us consider the problem given to Gauss, one of the three greatest mathematicians of all times along with Newton's and Archimedes. When he was just 10 years old, he was asked to find the sum of natural numbers from 1 to 100. He immediately replied that the sum is 5050. Can you guess how did he do? He wrote S is equal to 1 plus 2 plus 3 plus dot dot plus 98 plus 99 plus 100, and then he reversed the order of numbers and wrote x is equal to 100 plus 99 plus 98 plus dot 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 plus 3 plus 2 plus 1. On adding these two, he got 2s is equal to 101 plus 101 plus 101 plus dot dot plus 101 plus 101 plus 101 100 times. 2s is equal to 100 into 101 implies that s is equal to 100 into 101 divided by 2. That means 50 into 101 is equal to 5050. Right. Here we shall use the same technique to find the sum of first n term of an AP. Let A be the first term and D be the common difference of AP, consisting of n terms, and L be its last term. Then the AP is A, A plus D, A plus 2D, dot dot dot, and up to L. Right? So where L is equal to we can write A plus n minus 1 into D. Right? If S suffix n or S denoted the sum of first n terms of the AP, then we can write S suffix n is equal to A plus D plus A plus 2D plus dot dot plus L minus 2D plus L minus D plus L. Right? This is the number 1. Writing the terms of the AP in reverse order, we have Sn is equal to, we can write L plus L minus D plus L minus 2D plus dot dot plus A plus D plus A. This is the number 2 AP. Right. On adding 1 and 2, we get here 2Sn is equal to A plus L plus A plus L plus dot 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 plus A plus L in times, right? Now we can also write here 2 suffix n is equal to n into A plus L, implies that A suffix n is equal to n by 2 into A plus L, right? And this is the third AP. So we write here the value of L is equal to this one, A plus n minus 1 into D. From 3 we get S n is equal to n by 2 A plus n minus 1 D, right? So we can write here n by 2 into 2a plus n minus 1 d, right? Or we can write here S n is equal to n by 2 into A plus L, right? The formula Sn is equal to n by 2 into 2a plus n minus 1 into D for the sum of the first n terms of an AP, involves 4 quantities S suffix n, A, D and n. If we know any 3 of them, we can find the fourth quantity. In AP, A suffix n is equal to Sn minus S suffix n minus 1. S minus Sn minus 1 is equal to sum of the first n terms minus sum of the first n minus 1 terms is equal to nth terms is equal to A suffix n. Thus A suffix n is equal to Sn minus S suffix n minus 1. I hope student you clearly understand the derivation of S suffix n is equal to n by 2 into A plus L, right? My dear student, sum of first n natural numbers, the first n natural numbers, that is 1, 2, 3, 4 dot 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 up to n from an AP with A is equal to 1, D is equal to 1 and L is equal to N. Using the formula Sn is equal to N by 2 into A plus L. We get sum of the n natural numbers is equal to n by 2 into 1 plus n. That means n into n plus 1 by 2. Right, student? Now, dear children, for better understanding, we now discuss some example regarding this arithmetic progression. Here, some example is write the first term and the common difference. Number 1 example, 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2, and so on. Number 1, in this case, we solve this problem in this way. Here first term is equal to A is equal to 3 by 2, right? And common difference is equal to D is equal to half 1 by 2 minus 3 by 2. Here minus 1, right? Now another problem is here. The following AP minus 5, minus 1, minus 3, minus 7, and so on. Number 2, AP, their first term and the common difference will be first term is equal to A is equal to minus 5, right? And common difference is equal to D is equal to minus 1 minus 5. That means it will become minus 1, this one plus 5, it will become 4. This is the solution regarding the given AP. I hope student it will be very helpful for solve this type of the problem, right? Now dear student, here given some AP, which of the following list of the numbers from an AP justify your answer? Number 1, here solution A2 minus A1 is equal to 22 minus 11 is equal to 11, right? A3 minus A2 is equal to 33 minus 22 is equal to 11, right? And A4 minus A3 is equal to 44 minus 33 is equal to 11. It is same, right? Any term preceding term is equal to 11. A fixed number, that means it is a constant term. Hence we can write the given list of numbers from an AP, right? Hope student, this one clear for you. In the numbers from an AP, here in the sequence, here A2 minus A1 is equal to 2 minus 0 is equal to 2, right? A3 minus A2 is equal to 0 minus 2 is equal to minus 2, right? Implies that A2 minus A1 not equal to A3 minus A2. Hence we can write the given list of numbers does not from an AP, right? Number 2 is not a AP here. So number 3 is given here. The number sequence minus 1, minus 1, minus 1, minus 1, and so on. Now let's check is it AP or not. So here we write here A2 minus A1 is equal to minus 1 minus 1 is equal to minus 1 plus 1 is equal to 0. A3 minus A2 is equal to, we can write minus 1 minus 1 is equal to minus 1 plus 1 is equal to 0, right? And A4 minus A3 is equal to minus 1 minus 1 is equal to minus 1 plus 1 is equal to 0, right student? So here we observe in any terms, that is in any term preceding term is equal to 0. So a fixed or constant number, right? Constant number. So given list of numbers from an AP here. So given list of numbers from an AP, right? This also you understand very well. Number 4, the list of the numbers from here 2, 2 to the power 2, 2 to the power 3, 2 to the power 4, dot, dot, and so on. Here we check is it AP or not. Here A2 minus A1 is equal to, we can write 2 to the power 2 minus 2, that means 4 minus 2 is equal to 2. Right, student? A3 minus A2 is equal to, we can write 2 to the power q minus 2 to the power 2 is equal to, this one 8 minus 4 is equal to 4. Right? So implies that A2 minus A1 not equal to A3 minus A2. Right? So hence the given list of numbers does not from an AP. Right, student? Hope this one you clearly understand. Now next sequence, that means the list of number is here number 5, 1 by 2, 1 by 3, 1 by 4, 1 by 5, right? And so on. So let's check is it AP or not. That means it is from AP or not, right? Let's check how to find out. The same way that we write here A2 minus A1 is equal to 1 by 3 minus 1 by 2 is equal to, we can write LCM 6, and this one 2 minus 3 is equal to minus 1 by 6, right? And A3 minus A2 is equal to 1 by 4 minus 1 by 3 is equal to, we can write LCM 12 is there, so 3 minus 4 is equal to minus 1 by 12, right? So implies that A2 minus A1 not equal to A3 minus A2. Right? Hence we can write, hence given list of numbers is not or does not from an AP. Right? Student, I hope you clearly understand. Now, the last list numbers here, root 3, root 12, root 27, root 48, and so on. This list of numbers, is it from an AP or not? Let's justify. The given list of number is here root 3, root 12, root 27, root 48, and so on. So here we find out the A2 minus A1 is equal to 2 root 3 minus root 3 is equal to root 3. Right? Same way, root 3 minus root 2, A3 minus A2 is equal to, we can write 3 root 3 minus 2 root 3 is equal to root 3. Right? A4 minus A3, we can write 4 root 3 minus 3 root 3 is equal to root 3. Right? So, in this list of number, any terms preceding term is equal to root 3, which is fixed, which is a fixed or constant term, right, or number. Hence the given list of numbers from an AP. Right? So this example help you student to more improve about to understand the arithmetic progression. Now dear student, for more understanding the arithmetic progression, we solve more example regarding this chapter. Now the example number 3 here, write the first 6 term of an AP in which number A is equal to 2 and D is equal to 3, and number B, A is equal to 19 and d is equal to minus 6. So student, let's how to solve this problem you understand first. The first example number 3. The first 6 term are A is here 2, 5, 8, 11, 14, and 17, right. So number B is here 19, 33, 7, 1, minus 5, minus 11. Right. Here we use the general formula Tn is equal to A plus n minus 1 into d. In this formula, we have to find the first 6 term of an AP in which here A is equal to 2 and D is equal to which one? D is equal to this one, 3 is given, right. So the first 6 term, that means n is equal to 6 here. So we write here T6 is equal to 2 plus 6 minus 1 into 3. That mean it will become 2 plus 5 into 3. That means 2 plus this one 15, that means 17. Right student? This is the 6th term that we directly find out by this formula. Right student? I hope you clearly understand. My dear student, another example number 4 here is given. Write the 10th term of the AP 1, 5, 9. So AP is there 1, 5, 9, right. A dot P is equal to this one. Here the solution we can write here A is equal to 1, right. D is equal to, we can write T2 minus T1. That means it will become 5 minus 1 is equal to 4. Clear? So therefore T suffix 10 is equal to, we can write A plus 9D. Now put the value of the given data, right. So 1 plus 9 into D is equal to 4 here. So this will become 1 plus 36 is equal to 37. So this is the answer of the given problem, right. I hope student you clearly understand this problem. Student, here another problem, problem number 5. The third term of an AP in 44 and its seventh term is 28. Find its 11th term. Okay, so student, read this problem again and again and try to understand which way that we solve this problem. Here given T3 is equal to 44. Right. Third terms T3 is equal to 44 and seventh term T7 is equal to how much? 28 here, right? Now we can write, so A plus 2D is equal to 44 and A plus 6D is equal to 28. This one number 1 and this one number 2 equation right now. So on solving the two equation, we get A is equal to 52 and D is equal to -4, right? So the 11 terms, so T11 is equal to, we can write A plus n minus 1 D. It will become 52 plus 11 minus 1 into -4. That means 52 plus 10 into -4, right? So this one will become 52 minus 40. That means it will become 12, right? Therefore T11 is equal to 12. So we can write the 11th term is 12. This is the answer. I hope student, this problem and its solution, it's help you to improve your arithmetic progression, right? Number 6 example. Here we solve the given problem. The sum of three numbers in an AP is 45. The product of the first and the third numbers is 200. Find the numbers, right student? So let's try to solve this problem. Let the numbers be A minus D, A and A plus D. Okay, so we can write, so A minus D plus A plus A plus D is equal to 45, right? Now solve this equation that we will get here, dd cancel out, so implies that 3a is equal to 45, implies that a is equal to 45 divided by 3, that means it will become 15. Therefore a is equal to 15 here, right? Also we can write a minus d into a plus d is equal to 200. Now it is the formula, so this will become a square minus d square is equal to this one 200, right? This one given in the math. So here a is equal to 15, implies that a is equal to 15 square minus d square is equal to 200, implies that this one 225 minus d square is equal to 200, implies that here minus d square is equal to 200 minus 225, implies that minus d square is equal to minus 25, minus cancel out, so therefore d is equal to root over 25, that means this one plus minus 5, right? So the numbers are the numbers are 10, 15, 20 or 20, 15, 10. This is the answer regarding this problem. I hope student this will help you more understanding the arithmetic progression. Now dear student, the example number 7, here we find out if 3k minus 1, 2k plus 1, 3k plus 5 are the three numbers in an AP, find the numbers. Okay, so let's try find out the solution regarding this problem. For three numbers, numbers here is an AP, right? So we can write T2 minus T1 is equal to T3 minus T2. Before we already understand and find the list of number, is it AP or not. This test here we apply, right student? So here we can write 2k plus 1 minus 3k minus 1 is equal to 3k plus 5 minus 2k minus 1, right? 2k plus 1. So implies that open the bracket and calculate the k. Here we calculate 2k plus 1 minus 3k plus 1 is equal to 3k plus 5 minus 2k minus 1, implies that here this one minus k and this one plus 2 is equal to k plus 4. So implies that k is equal to minus 2, right? So we can write the numbers are here minus 4, okay, minus 1 and 2. So this is the solution regarding this problem. Now my dear student, here we understand on sum of numbers in AP. The example number 8, here the problem is find 1 plus 4 plus 7 plus ... 220 terms. So he had given 1 plus 4 plus 7 plus ... 220 terms, right? Now the solution regarding this problem, here we can write a is equal to 1, d is equal to 3 and n is equal to 20. Now using the formula we can write here Sn is equal to Fn, that means n is equal to 20 here. So here we write 20. S20 is equal to 20 by 2 in the bracket 2 into a, that means 2 into 1 plus 19 up to before 90, 20 before 90 into the common difference 3 here. So this will become 10 and this one 20, 10, that means this one 59, right? So this one will be become multiply this 590. Here 2 1 is 2 and this one 57, so 59 is here, right? I hope you clearly understand this problem, right? Now my dear student, another problem is here. Find the sum of 5, 11, 17, 119. Same, here this problem we solved out. Here given here a is equal to 5, d is equal to 6 and t n is equal to 119, right? So therefore we write here In this formula, 5 plus n minus 1, 6 is equal to 119. Okay, so implies that here this one 5 and this one 5 and this one, it will become plus n minus 1 into 6 is equal to 119. Okay, so now this one became n minus 1 into 6 is equal to 19 minus 5. That means this one became 114. Implies that n minus 1 is equal to, now divide by 114 by 6 is equal to this one 1, this one 19. Implies that n is equal to 20, right? So we can write 20 by 2, 1 plus 19 into 6. That means it will become 10 into 10 plus this one 4, 1 carry, this one became this one 5, this one 11. Now this one will become 124. That means 1240. This is the answer regarding this problem. Right, student? I hope you clearly understand this problem.